In modern cybersecurity, detection alone is not enough. Response speed determines whether infrastructure survives or not. This is an Aegis AI Overwatch, an AI-powered DDoS defense console trained on CI/CD DDoS dataset, delivering over 95% detection accuracy. This system classifies the network behavior using 8 optimized features, and when threat is detected, it doesn't just raise an alert. It immediately pushes the source IP into the integrated firewall. Let me show you how the architecture, machine learning pipeline, and tactical blocking system work together. Hello guys, welcome to next video by Project Maker. So as you can see on the screen, this is my detection console of simulation which can behave exactly when you place this project before the firewall to filter the DDoS attack flows. DDoS means distributed denial of service. This project can be simply placed between the company firewall and the incoming request. So this project can simply scan out the DDoS attack and simply add those IP address into the blocked IP list of firewall. So let's directly understand this simulation. I would like to show the project demo first, then I can explain you what is happening in the backend. So assume you have an application server and it gets daily 10,000, 20,000 hits. So you can place this project in front of your server. This system can simply filter out actual attacks and valid hits to the server. So let's keep this as same, and if I hit enter and it's showing that this is the IP address and it is malicious DOS if you can see, and this is the location of that IP address. And for your information, I have taken this data from the dataset on which all the models are trained. And let's change the model. Let's set to XGBoost, and I will simply make it to 7 and simply hit this initiate active scan button. And as you can see, there were few positive flows also and negative flows also. Negative flow in the sense they were attacks. And if you can see in front of the every response, this is the block button. If you simply click on this block button, this IP will get blocked and it will never come again. And if someone tries to access your server using this IP, the system will automatically block without taking your permission, as you are manually allowed to block this IP address. And if you can see, this is the IP address which is 192.168.1.208. And if you want to see the list of blocked IPs, you can see it here. And this was the IP that we just blocked, and this was the previous IP that I blocked previously while testing this project. If you can see, I executed this project some time before, and these are the timestamps, signature, status. Big means it's a positive hit, so it can go ahead, and origin is internal, action should be no action. So this is the about security logs, which simply keeps data about all the hits that were made on your server. So this was the simulation code. But what if you want to see the manual status of any flow? For that, I have created this manual probe, and it works in the same way. The difference is that you can just manually add the details, which is flow duration, flow bytes, and so on. And after you added all this field, it will simply tell you that it is a DDoS attack or it was a normal flow which should be allowed. So let's simply take some random values from dataset. So I have already created this button which says that inject random tactical profile. And if you can see, this is B5 volt SIP. So I will simply select this model for right now and simply click on this execute. And if you can see, this is the traffic profile bin, and this green, which means it's a clean record that is taken from the dataset. And if you want to see a false record, which is this, and if I simply run the same model on this, it will show that it's DDoS pattern detected and the accuracy of it, which is 91.6%. And if you go ahead like M3, and if you change the model to SVM, it will simply show the same, which is DDoS pattern detected. And suppose let's select some other. So if I select this P1 standard web browsing, and let's select this SVM complex pattern, and if I simply click here, it's saying that traffic profile bin, which means it's a true hit to the system and you can allow, and the accuracy is 78.8%. So this was the main idea and the output of this project that I just tried to demonstrate it using the simulation and manual entries. Anyways, you can just replace this value and add your own value if you have the dataset or if you want to test this application. So this was the main output of my project. Now let's understand the project, that how I created it. So I will simply go to this command center, and if you can see, this is the active protected nodes, which is 128. Threats mitigated is 42. So up till now, in last 24 hours, 42 threats were detected and they were mitigated also. Neural engine load is 14%, so your engine is reduced, and system integrity it's currently showing secured. And this is simply mission briefing, which tells you basic idea about the project. So this was the command dashboard, and it has neural ensemble, live overwatch, sentiment protocol, truth engine. And if I simply go to next, which is intelligent metrics, Aegis AI relies on sophisticated 8 signal telemetry area to fingerprint network behavior, which means it highly depends on the 8 optimized feature, and based on that it provides the output. And the feature names are flow duration, total forward packets, forward length, total packet seconds, byte seconds, packet mean, packet standards, and down up ratio. So when you hit a server, let's say google.com, a 30 to 40 features of your single hit are generated, and based on that your access to that server is approved or not. And this project does the same. Based on the 30 to 40 feature, I have selected the top 8 most optimized features. And when you hit the server, it will simply extract these 8 features. And based on these 8 features, it will predict that whether your hit was valid or it was just DDoS attack. And visual intelligence is that live threat map. So I showed you the threat map, jitter logic, and AI context. And let's see the system blueprint. So this is the system architecture. If you can see the client layer, interactive dashboard, which is this simulation controller, visualization engine. So this is entire visualization engine. Then simulation control takes the random data set based on the user selected and simply passes to data processing. And after processing is done, it simply shows the output. And if I just manually click on any IP to block, it will simply alert the firewall and it will block that IP address. Whenever someone tries to access your server using that IP address, it will directly block. So moving forward, this is the ER diagram of this system. You can take a close look to it, which is packet flow model, detection event, firewall rule. And this is the data flow diagram, which is admin dashboard, AI engine, log rules. And coming to this is the manual neural probe that I already demonstrated. Coming next, this is the simulation console. I specifically created the simulation console for you so that you can understand what could happen in real time and how this system can block DDoS attacks. So let's try it for just one more time. And if I just added 10 and the max flow count is 10, so if I simply click, and if you can see, 8 flows are directly taken from the dataset, and based on that the output is done. The first is valid, second is valid, the fourth is malicious. And if you can see, IP address is 168.11.1.144, and this is available here. And if you can see, this is the target, which is 10.0.1. This is the origin, and the target of that origin was 10.0.1, which is this. So assuming that the destination or the server IP is 10.0.0.1 and it has successfully identified, and if you want to block it, just simply click on this block button and it will get blocked. When you initiate the simulation once again, if any attack comes from this IP address, it will directly block it. And you have already seen the security logs, and if you can see, this is the IP address that we just blocked in front of you. And this is the list of all hits that were done on your server. And moving to this last, which is 10 analysis, it simply shows the accuracy of the model and basic idea that how the model was trained, what are the insights. So this is classification that I simply done on the dataset. And if you can see, static analysis of dataset, and if you can see, this is the all model accuracy comparison. So if you can see, logistic regression is giving 89% accuracy, random forest 99%, XGBoost the same, and SVM 97%. And also I test all these models in new dataset, and the accuracy has remained almost the same. This ensures that the system was highly trained and it's capable to block any DDoS attack happening on your server. Moving further, this is the feature correlation. This is the model performance matrix of random forest. And all of these images I have simply taken from the Jupyter file, where I manually loaded the data that I received from internet, and I have taken this dataset from Kaggle, which is this. So I have simply taken this dataset from this Kaggle website, full dataset CSV, and if you can see, this is the basic information of dataset. So if you want to know basic idea about this, it's a dataset that contains being and most up to date common DDoS attacks that happen on real world data. And if you can see, the size is 30 GB, means I have loaded a tons of data and tested it. That's why the accuracy is about 95 and it's performing great even on unseen data. So this was all about my project, and these are the further metrics of each model like XGBoost, SVM, and logistic regression. So for each model I have added accuracy, precision, recoil, F1 score, and AUC. So this was my Aegis AI system, which can be one of the best shield for your server, and this will help to block all the DDoS attacks and allow only valid flows to access your server. Now let's move to the command center. So this was all about my project Aegis AI, which is an Overwatch system. If you like this project and you are interested in the source code or the train Jupyter file that I just created for this project, which is this. So this is the training and testing dataset, and this is the dummy samples.json that comes here when I simply click manual probe and click on these buttons. So there are 8 to 10 samples present in this file, and this is the Jupyter file where all the data pre-processing and main pipeline is present. Now let's move to the console once again. If you are interested in studying this project in deep and you want the Jupyter file, all the entire project, then drop a comment down, or you can also DM me on Instagram for the source code. I would be happy to share you the source code of this project. Also, if you have any feedback related to this project or any other project that I post on YouTube channel, then please let me know your suggestions so I can improve this project and make it perfect so that it can prevent every DDoS attack happening on every system in the world right now. So that's all about this video. Thanks for watching this video.